Okay, so I'm going to talk about how PHP objects have been designed in the engine for PHP 5. Some slides are quite charged with lots of writings or code, so don't worry about this. It's mainly because I used to be, well, I'm still a trainer, so I give trainings, I like sharing my knowledge, and this is much more about sharing knowledge. And as you will be able to pick up the slides after, so you can read them back and you have some codes and some examples. So that's why sometimes you will see slides like this, so don't be scared. So I'm Julien, I'm working in Paris for Synthio Labs. We mainly develop the Symfony 2 framework. I'm PHP 5.5 and 5.6 release manager, and I mainly put my head every day in PHP internals code, which is about 800,000 lines of code. This is just about 1 million lines of code, not too far. I'm writing actually a book, PHP internals book, together with other contributors to share knowledge about how PHP has been designed internally, because it's quite hard to put your head in the code at the first time. So that's why I'm writing this book. So what we'll cover together is a quick recall on how PHP manages variables. Then we'll dive quickly into objects and object structures. There are some C code lines, because PHP has been written in C, so I guess you have knowledge about this. And we'll then talk about PHP object lifecycles, memory usage, order of destructors, class compiling, etc., etc. So stuff very technical sometimes, but that's the point, and the garbage collector as well. So a quick recall on zval. So this is just to remind you that PHP is able to manage many types, many data types in variables. So those variables, $, something, are internally stored in what we call zval structures. Okay, and zval structures can actually manage all PHP types, okay, in the value field. So the longs, the doubles, the character, the strings, the arrays, hash tables, and the objects, okay, which are Zend object values. So that's the point. Zval have internally a very big, very huge API, okay? You can allocate memory, you can change types, you can free memory, and you can play with reference counting. I'm gonna show you what is reference counting. This is a mechanism for PHP to save memory. So PHP is has a very low memory footprint. This is a trick to shrink memory usage. This is called reference counting, so I'm going to show you after how it works. So every PHP variable is a zval internally, and when you have several variables pointing to the same object, to the same part of memory, so PHP just increments the ref count. Okay, so in this example, you have created one object and you have actually two PHP variables pointing to the same object. So yes, the object is not duplicated in memory. Okay, you can have many variables pointing to the same object or to the same long or array or whatever you want. PHP does not duplicate the memory containers. So basically, when you create a variable and you affect something into it, you have a ref count of 1, and then you play with this variable. You pass it to functions, to classes, and to I don't know what. And So the ref count will be incremented each time you add a variable to the same zval, and each time the variable is changing scope. So when you pass a variable to a function, the engine increments its ref count because the function is going to use the variable, and it decrements it when the function exits. Okay, same with method. And PHP does not free the variable memory, the zval memory, until the ref count reaches 0. Okay, so that's the point. So in our case, we'll talk about zval using objects, and not arrays and strings, stuff like that. We just stay with objects. So a statement, objects are variables, variables are zvals, and objects are not freed until their zvals ref count reaches 0. Okay, so I try to give a statement based on what code has been written for PHP, because I train many people, I go on many mailing lists and forums, and many times I read things which are just wrong. Okay, so the right things are written in source code and not in forums and things like that. So that's why I'm trying to show you. Okay, so you can read so many bullshit. So that's why I try to tell people how it really works internally. So objects. Now we're going to talk about objects. So in the zval container, when you address an object, PHP uses the obj field. The obj field is of type send object value, and the send object value structures is send object handle and then object handlers. Okay, you have two things in an object. This is not yet the real object. Okay, the handle is an internal number which is unique and which uniquely represents an object, and it's exposed to PHP land through a function you should know, which is SPL object hash, okay, which just hashes the handle and the handlers together and gives you a string which uniquely represent the object in memory. And this hash, you also can see it when you use var_dem. So you have a handle and some handlers, and the handle is a unique integer designed to fetch the real object from a store. Okay, the store is a container in PHP memory which contains each object uniquely, and many zvals may point to those objects. Okay, that's the point. So if you want to see the real object handle, you just var_dump your object, and you have something which is a hash number, and this number is the internal PHP number. So here we can see that we var_dump 3 variables, and we are sure that they all point to the same object because the var_dump function gives us a hash1 for each object, for each zval, for each variable. So it's the same object which is pointed. If the hash changes, then it's not the same object. Objects are not references. Okay, this is something, isn't it written on php.net? I should check this and fix this quickly if it's written. They are not references. This is a simple proof. Okay, objects are not references because if you use, if you create an object and pass the variable which points this object to a function like a normal variable, no reference, okay, just a copy. When you change this variable and you dump it after, you see it hasn't changed, so it's not a reference, okay? Object borrow reference behavior, they give you the illusion you have references even if you don't use the ampersand sign, because internally the zval encapsulates the same object handle. Okay, so when you create a PHP variable with an object, you have a handle and you pass this variable somewhere. It can be copied but it still points to the same objects internally. So you have to make the difference between the zval, which is the variable, the dollar something, and the objects, which is pointed internally in it. Okay, when you write dollar object equals some string, you just overwrite the zval. Okay, so you change its type. Before it was an object, now it's a string. Okay. But the object which was pointed by the zval may still be alive because other variables before could point to this object, so it won't be freed. And when you access with the arrow sign an attribute of this object, you effectively change the object which is into the zval, into the variables. So if you want to a drawing, this is what is done internally in memory. Okay, so that's what I just explained. Whenever you change dollar something, you change the zval container, and whenever you access through a variable arrow something, you access the object which is pointed by the zval into it. There are only two ways to create a new object in the store: the new keyword and the clone keyword. That's all. Okay, so you can just get a .php file, a simple one, and you count the number of new and the number of clone, and you have the exact number of objects which are allocated in PHP memory. That can be another way. Okay, so if you have $a equal new, this is one object, and clone, so there are two objects in memory. Whatever variables you pass anywhere to functions, references or not, actually I can count one new and one clone, so into memory there is two objects. There are two objects. So even if you force PHP to duplicate the zval by playing badly with references, what people usually do when they use references, the object won't be copied into memory. Okay, do not use references. This is another talk I give usually, because when you use references, you change the copy and write behavior of the engine, and basically, mainly, you force PHP to duplicate the zval and the memory, and you were thinking about the opposite, saving memory. So do not use references. If you don't really need references, do not use them, okay? PHP has been designed so that you don't usually use them. So PHP is cool about memory usage if you don't use references. If you do, PHP will start duplicating zval content. So if a zval content was a string, if you play with references, PHP will somewhere duplicate memory, particularly when you pass the variable to a function. Okay, PHP does not duplicate memory if it's not a reference. If it's a reference, it's going to duplicate it. Okay, so that's the trick. And duplicate the memory of the container. Should it be a string, an array, it can be very heavy. When it's an object, there is another trick. It's that PHP does not duplicate it. Okay, this is the PHP 5 behavior against the PHP 4 behavior. This is the real change. So whenever you use references, you see that here you have two zvals because I used a reference, so I forced PHP at one time to duplicate them because I changed them in some scope which make PHP duplicate them, but PHP duplicated only the zval and they still point to the same object internally, which is not the case if it's not an object. Okay, if it's not an object, when PHP duplicates a zval, it duplicates the content into the zval. Should it be a very huge string or array, you will burn lots of CPU cycles, and you can see this if you use a low-level profile. You can see this very easily. So first step, conclusion, which is important about things I read on forums and I'm told about. Having lots of variables pointing to the same object is not bad for memory usage, okay? clone and new are the only ways to create new objects in memory. PHP will never create an object in memory if it does not meet the new or the clone keyword. Okay, so that's important. To destroy an object from memory, you must disconnect all the zvals which pointed to this object. And this can be very tricky. Keeping track of this can be very hard. If you use Xdebug, you can see the ref count of each zval. That can be very nice, but the best is to master your code and to know what you do, to know what happens in memory when you play with PHP variables. This is to remember what happens. This is better, because actually we don't have tools to draw a picture of PHP memory or things like that. We could work on things like that, but we have no time actually to do this, so you cannot really know what happens. You can compile PHP with debug flags and you can patch its source. You have lots of defines which are 0 by default. You put them to 1 and then you have lots of things coming to STD error, standard error on your process, and it shows you when it creates, when it allocates, when it deallocates objects. It just writes one line of log. That can be a poor debugger about this. Talking about garbage collector, this is wrong. This is a circular reference garbage collector, okay? Because PHP garbage collector is not object specific, okay? That's another thing I can hear about PHP memory objects or garbage collector. This has nothing to do with Java 1. This is absolutely not the same technology. I recall you that Java, some part of Java are open source, and PHP is open source. You are free to compare their own garbage collector, and you will see they are not based on the same technology at all, and they don't do the same thing at all, so please don't write this on forums. PHP garbage collector is a circular reference. Its only goal is to free circular references in compound zvals, which should be arrays or objects, that's all. PHP has always freed unused zvals of which ref count reached 0, okay? Garbage collector has nothing to do with this. It appeared in 5.3, so it frees circular references. This is a circular reference, okay? So this circular reference is just one object pointing to the other, and they self-point to each other. This is an easy one involving two objects, but you can have circular references, A pointing to B, pointing to C, and C point to A, and A point to C, C to B. So you have a circular reference involving three objects. So in this script, I create two objects, I make them point each other, and then I unset the zvals, but PHP cannot free them because they still own each other. Okay, but you as PHP developer, when you unset the two variables, you have you cannot access those objects anymore. Okay, but PHP still keeps them in memory because they still point to each other. So their ref count is 1, it's not 0, so it will never free the memory. Okay, so that's a problem. That's why we have a garbage collector, which will eat them. You can trigger it by using GC collect cycles, and it will tell you how many zval it actually freed from memory. Okay, so there are two objects. They could be arrays as well, but with arrays you have to play with references if you want to really have circular references. So it's better to show with objects because it's much more easy to do. It's very, very easy to have circular references. As soon as you pass this to another object, and this object uses yourself, and this object passes itself this to the other. So this is a circular reference, and it's a little bit more tricky to watch at the first time. So on the right, I created a circular reference leak, and I did not notice it. Are there? No, they are not here. Doctrine to Doctrine 2, you wrote some Doctrine 2? So when I see the entity manager creates the unit of works and it passes itself and then back, and then you have lots of many objects, you just try to unset your entity manager and all the structures behind it stay in memory for too many time. That's by design of Doctrine 2, why not? But that's really bad because those objects as well are very heavy because they have lots of things into them. And you have, like, I can't remember, but you just open the entity manager code and you just see its construct. It passes this to two objects which themselves affect themselves to it. So that's absolutely very bad. And from my experience, because we had long living processes and Symfony 2 commands and things like that, and even if you unset your objects, you have to GC collect cycles very often because of circular references actually. So if you want to dive into object, let's go. What is an object in PHP? An object is a send object. This is actually the true object in memory. Okay, this is it has a class entry and it has properties and property table. We're gonna show what's the difference about there. As we've seen, PHP does all it can to not duplicate an object in the store. Okay, if you want to duplicate an object in the store in PHP memory, you have to use the clone keyword. So properties and properties table, this is a little bit tricky. Anyway, try to declare PHP object attributes in a class and try not to affect them at runtime. This is bad for memory, okay? Even if in 5.4 and in 5.5 we optimize this in lots of ways, so we use caches in the engine, and lots of caches actually are used in the engine for PHP. So that's not so bad, but in 5.3 that's not the same design anyway. So 5.3 to 5.4 we nearly rewrote all internally, but you cannot see this from the external API from PHP land. But extension managers have seen this. They had trouble to port their extensions to 5.4. That's why. What is a class? So a class is huge in PHP. A class actually consumes lots of memory, okay? But it consumes memory once. You can have thousands of objects of the same class. The class is unique, okay? It's this slide, the structure has been shrinked. If you want to see the real structure under there, you have the same okay, like this, to divide it. It's been shrinked at 50%. You have lots and lots and lots of other things, so you have many things into it. And you can see that you have a function table, properties information, default properties table, default static members table, constant tables, default property count, etc., etc., etc. Lots of function pointers that you can redefine, iterators and other things down there. I cannot show you because it's too big and it's not really interesting to see. You have in the source code anyway. So this is important. Object declared attributes are stored once in the class structure at compile time. So whenever the compiler meets a class, it gets all the attributes you declare, and it allocates memory and it puts this in the class. But whenever you create an object, PHP will read all those attributes and duplicates all them in the object memory so that the object owns its own properties, which has nothing to do with the other object next to it. Okay, so when you have a $01 equals new a class, $02 equals new a class, when you change $02 attributes, you don't see the change on $01. Fortunately, that's nice. Okay, so it's going to duplicate all them. That's why you cannot have attributes of array type or even of object type at compile time. Okay, only scalars, because we can make lots of hashes and lots of optimization when we pass the code, and when we compile it, we make cache slots for later access and things like that. So you have a private copy is made tied to the object. So conclusion, an object weight is directly bound to its attributes weight. So when you have a class with many attributes, every object of this class will have a bigger weight memory footprint than if you had just a class with one attribute or with no attributes at all. It's useless, but class information are shared between objects, so this is important. The class structure, which is huge, is never duplicated, never copied, okay? Just the attributes are copied to every object, to every new or clone you do, okay? PHP duplicates all the attributes and all their values. So every declared property is stored in the class structure with information and lots of things. So that's what I just said. So the class consumes much more memory. Even a class with nothing, okay, see, if I go back to show you back the class, if you just declare a class A, you will allocate destructor. Okay, a pointer is 8 bytes, 64 CPU. Hash table is even more. An integer is 4 bytes. So just compute it. It's more than 100 bytes for one class. This is pretty huge. Internal classes can optimize some things, but they are mainly Zen classes as well. This is the type, the first field type, which says if it's an internal class or an external class, and the flags as well. Flags can embed the information like how many, do you implement interfaces? Are you an abstract class? This is just bit fields with pipes between them. So lifetimes, objects start living when you create them and stop living when they are destroyed. To destroy them, you have to destroy all the zvals pointing to those objects. Classes start living when PHP starts parsing a T-class token. Okay, so this is class something. Classes stop living when PHP shuts down. Okay, so a class, when you compile it in PHP and you run PHP and you have a while true, for example, or something like that, the class will never get freed from memory. Okay, it's freed when PHP shuts down, when you have nothing more to do. PHP frees the class, and it frees the hash table about its properties, static properties, okay? Classes properties, that's why you cannot unset them. You cannot unset a class, double colon, dollar variable, you will have a warning or something like that, or a fatal error, and this is worse, because PHP destroys the static variables itself, okay? So everything which is static, this is somehow logical, we will leave for all PHP lifetime, okay? It will never be freed. Object handlers. So an object also has send object handlers, if you remember, and handlers, they are self-describing, so they can let you do whatever you want. And what I love is when you create extension, you can actually overwrite every handler. So if I want to overwrite the handler, which is called addref, I can do it in an extension, which is pretty nice. You can do many things. There are many things in PHP objects which have not been hard-coded. There are lots of levels of indirection so that you can hook at anywhere in the code, in the engine when you develop extension or patches, and you can do many things. From PHP land, you also can, but you are very limited. So every single tiny operation on objects is done using a handler. Okay, so this is interesting. Casting an object can be redefined comparing an object can be redefined, and lots of things can be redefined, lots of things which has been asked from PHP users can actually be done and internally, but cannot be done from PHP land, unfortunately, because the compiler does not allow it, but you can do many things, like comparing objects. This is interesting to do when you compare $01 equals $02 or is greater, is less than. So by default, the engine will say always true. It's you cannot override this from PHP land, but you can override this when you develop extensions. So the default handlers are all there, then standard write dimension, then standard read dimension, etc., etc. Some are null. This is how you do. So you cannot count elements by default, but if the compiler sees that you implement countable, it will change this pointer to something which will call the count function for you. So you can do things as well from PHP land. Default handlers implement default behavior we are all used to. So this is the handler, which is quite simplified. Then standard get method. Does the method exist in the class entry function tables? If not, has the class entry a call? Yes, call it. Okay, that's the default behavior you all know. You should know about special behaving PHP objects, PHP which are pretty strange to use. PHP objects which are not from classes. You should know about simple XML element, which is quite virtual attributes representing the XML nodes. All the handlers has been redefined in simple XML element. That time as well, that time has redefined the compare. You can compare two datetime objects and it compare the dates inside the object, because we redefine the compare handler of datetime so that it does not use nothing. It compares internally things. You can do many things internally from PHP. You, as PHP developers as well, can tell PHP to redefine some handlers. When you use array access, serializable, countable, you can redefine lots of handlers. And if you develop PHP extension, you can even redefine more handlers. Gotchas, you have lots in PHP OOP. So this one is very tricky. So I guess nobody can answer it, except if you follow me on Twitter, because I posted it something like 2 weeks ago or something like that. So look at this. I have a new standard class with $a equal 5. If I varden $a, PHP tells me, oh, I don't know $a. Okay, let's try with another class. New datetime $a equals now. Do you know $a? Yes. So this is quite strange. Can you guess why? Does anyone? No. Yes, this is related to the constructor because standard class has no constructor. So if it has no constructor, there is something in the compiler which optimizes the code and just sees, okay, you want to create an object of class standard class. It does not have constructor, so I don't bother parsing what's all in the parentheses. I just go in the next opcode. This is quite complicated, but that time has a constructor, okay? It accepts arguments, so the compiler will effectively execute $a equals now first, then the result will be given to the constructor of that time. This is quite tricky, but this is a gotcha. It's, PHP. This is written in the source code, so. Destructors, so many secrets. I love this part because there are so many questions about destructors. So now I'm gonna show you what to do and what not to do with __ destruct function. calling underscore destruct when the engine calls it, it does not mean it's going to free the object, okay? Because the destructor can play with other objects which their own destructors could have been called before, but if the object is freed, then there is a problem. Okay, so I'm going to show you how all those works. So an object is destroyed when no more zval point to it. So this is how PHP actually destroys it. So you create an object, you unset it. Yeah, fortunately, obviously, there is no other pointer to the object. So the ref count reaches 0, and destruct will be called. So let's now see what happens at shutdown. Shutdown is when you don't care about destructing your own objects, and you say, okay, anyway, PHP will free the resources for me. And you will see that PHP will do this in such a way that that's bad. Okay, so do not let PHP destroy your objects. That's quite hard to do nowadays because we use too many objects, but let's see how PHP does. The cleanup sequence. The cleanup sequence is clearly written in the source code, which is accessible to everybody. It's done in 3 main steps, okay, which I underlined here. This is just code, and then I explain it on the next slides. So you have 3 phases, 3 steps when you want to let PHP destroy your objects. The first thing it's going to do, it's PHP will loop backward the global symbol table and destroy objects which zvals refcount equal 1. Okay? So on the left, on the middle, and on the right, you have this explained. I create foo, I create bar, and I let PHP shut down. So it starts by destroying bar, then foo. If I swap, the same happens. If I change the ref count of an object, it's not 1 anymore, it's 2, so the order is changed. Okay? This is, I go back, this is number 1. Then hash reverse apply the zval call destructor, which checks it's an object and the ref count is 1, to the symbol table. Okay? The second step is to then object store call destructors on this same store. Okay? So when the second step happens, no more objects with ref count 1, only solo objects, which were just used at one place, can leave now. Okay? So at the second step, then, for objects where ref count was greater than 1, PHP will loop forward the object store and destroy all objects in their order of creation. So, because this is forward. Okay? So this is the trick. You create foo, just not to have ref count equal 1, you just affect another variable, so you have ref count 2, okay? You create bar, and then you can see that foo is destroyed before bar, okay? If they were with ref count equal 1, and what's the opposite, okay? And then at last, PHP will mark all objects as destructed, and you have many tricks, and that I will show you. If a destructor exits or dies, the other destructors are not executed. Okay, this can be tricky. But the objects are marked as destruct. This is the third step. Okay, this was in red, I think. So this is, I create an object foo, I create that object bar, but in the foo destruct I call die. So the foo destruct will be called, but not the bar one. Okay? So knowing that, you can meet weird behaviors. Okay, this one I'll let you read it and compute it by yourself. And it seems like, yes, I am able to reuse an object which has been marked as destroyed by PHP. Okay, as you can see, I create foo, I create bar, I pass foo to bar, then I let PHP destroy my object, so it's gonna use the trick I told you before. It's going to first destroy the object where the ref count was 1, which is bar. Then it will destroy foo. And then if you change this by affecting another variable to bar, you make its ref count go to 2, so it goes in the second destruct line, so it goes forward. So PHP is gonna do some things that let you think that PHP can run destructors that it should not be able to run, but it can run them. As you can see, in the destruct of bar, I access foo states, and foo states can be changed. It depends on the ref count, so the number of PHP variables pointing to an object. So that's quite tricky. And when you destroy an object, PHP will free it, okay? And when PHP destroys an object during shutdown, it will call destruct and not free the object immediately, okay? Because as you can see on the preceding slide, objects in destructors can still point to each other. So if it goes and freeing them, it's going to have a dangling pointer. This is a crash. This is a seg fault of the process, usually. If it's not worse, it cannot be. Okay, so the objects will be freed when the engine will shut down. So the shutdown sequence, which is detailed on this link, is detailed here. You call shutdown functions. You call object destructors. Everything which happens after this, which uses objects, can crash PHP. Like error handlers using objects, output buffering using objects as callbacks can crash PHP as well. Just don't do this. I cannot say anything else because we changed this shutdown sequence in the past. So people were angry against us because there were things strange from one version to another version. But why don't you free yourself, your objects? Don't rely on PHP free behavior because PHP is written in C, and at one moment we are not wizards, we cannot guess what you want to do. We have to shut down PHP in such a safe way, but there is no really safe way to shut it down. Okay, we try to patch it version after version, but don't rely on PHP's shutdown behavior. It has changed, it will change, and it can make PHP crash. So don't use objects as callbacks of error handlers, of output buffering handlers, and things like that, because when they are used, when those handlers are used, the destructors and the object stores has already been marked as destroyed, and you can do things which are just bad for PHP. So just free the resources yourself. Next trick, the function stacks which get serialized. This is quite tricky as well. When you serialize an exception, it serializes the stack trace, and the stack trace itself could not be serializable. So as you can see, you know perhaps, or you don't know, simple XML element objects cannot be serialized, okay? So if you pass them to a function and the function body tries to serialize an exception, the serializer handler of the exception will get the backtrace and will try to serialize all the backtrace, and the backtrace is in a function which had an argument which was an object which was not serializable. So yes, we are not wizards. We cannot make magical stuff and magical things. So you will have an exception which is a little bit strange, uncaught exception with message serialization of simple XML element, but you asked to serialize an exception, not a simple XML element, okay? So you should be aware of that. This is the same, this is written in the source code in the exception class serializer. You can see, and if you run GDB or things like that, you can see what happens, and yes, sure, that cannot work. And the last one is the early binding, which is even more complicated. There's something strange between those two codes. Class C extends B, class B extends A, class A, fatal error. Class B not found. Class C extends A, class A. All right, what happens? It happens many things under the hood. What I can say is use an autoloader. Nowadays with Composer, it's very, very easy to use to manage autoloading in PHP, and try, if you don't use an autoloader, to declare your classes in the right order, the order where they appear to use each other. Because when PHP meets the extends keyword, it's going to try to fetch the class immediately and not run the code under it. Okay, and if it cannot find the class, then it's gonna. There is a trick which is called early binding. This is we try to do many things at compile time so that the execution time is reduced. You know. And as you compile your script only once because you use an OP cache solution, we try to do many things at compile time. And when we meet classes, there are many tricks which are used. And in PHP is a dynamic language, so you can declare classes, which is bad, but conditionally in if statements. That's why we have what we call early binding and late binding and lots of things like that. So try to declare your class in the right order and use an autoloader so that, I guess nowadays you use, everybody uses an autoloader nowadays, no? Yes, I guess you do. So autoloading is, wow, I cannot really say that, but it's not really bad for performance. Actually, it's pretty nice for performance to have an autoloader, because you make PHP parse the class when it really uses it and not when it does not need it. As you can see, a class, you have seen, a class is has a very huge memory footprint, and do not make PHP parse a class if you never use it, okay? And you cannot really know when you have a very huge framework and very huge libraries, you cannot really know if such an object is going to be, such a class, it's going to be used or not. So so you try to put all the classes in the same file. This is bad for memory usage. So the autoloader is quite optimized nowadays. We are still working on optimizing it. There are things that can be done internally. And if you use an OP cache solution like APC or OP cache or whatever you want, PHP anyway just passes the class once and then keeps this in memory, in shared memory for every process, which is quite nice. So try to use an autoloader. We used to say, oh, do not use autoloader because you're going to call a function at runtime to load your class. Yes, but you're going to call it just once, and usually when you warm up your caches, you just curl your API so that everything gets compiled, and then you can just get rid of those class orders, and you use an autoloader. It just runs. It's just all right. So use it. It's nice. And that's all about PHP object design. Thank you for listening.